Okay, in lesson 4.5, we're going to go over direct variation. The formula for direct variation, and you need to memorize this, is y equals k times x. The most important thing in this equation is this letter k right here. And what the k is the constant of variation. That means I'm going to have an equation that looks like this, y equals 2x. 2 is in the spot where k goes, okay? So 2 would be my k, and x and y vary. That means no matter what, I can plug in any number I want for x and I can always find what y equals. Or I can plug in any number for y and always find what x equals as long as I know this constant of variation. So that's why it is so important. The whole point of this lesson is to find k. So you're going to look for k or solve for k and plug it back into the equation. So you need to memorize this formula, y equals kx, knowing that k is always what you're looking for. So first of all, in the first example, all they want us to do is find the slope and the constant of variation. Well, guess what? The slope and the constant of variation is always the same thing. Always the same thing. It's never anything different. So if this is y equals k times x, k is my constant. Well, this is k right here. So my slope, so m and k equals -3 in this first one. And you can just write m and k because we know the formula, or we know that the slope is represented by m, and k is my constant of variation. So let's do the same thing. What would your slope and constant of variation be in this next problem? 3/4, exactly. Okay, so those are my answers there. Constant of variation and slope are always the exact same number. Now, this is the part that I really want to spend some time on. Write a direct variation equation. So the variables x and y vary directly. That's what they're going to say. First of all, write an equation. Y equals k times x. We know that is direct variation. What am I always looking for? K. Look at what they gave me. They gave me x and they gave me y. They did not give me k. So what I need to do is I need to plug these numbers in and solve for k. That's all you need to do. So I know I have 20 equals k times 5. Now, I want to get k by itself, so I divide by 5, and I get k is equal to 4. Now, this is not your answer. Do not box that in and say k equals 4. What they're looking for is for you to write an equation right here. Write an equation. So, even though I know what x and y are, I've got to plug it in as if I do not know them at all. Y equals 4 times x. The only thing you are plugging back in is k. The only thing. Because what they want you to do is they want you to know that variation. So I can say, okay, what if x were to be 25? Well, I could plug that in and find what y is. That's why you leave the x and y blank. So once you find k, you have to write it as an equation. Y equals 4 times x. Only plug k back in. Okay? Now, in the second step, what they want you to do is find the value of y when x is equal to 10. So this was the whole point, remember? Find the value of y. I know my constant, which is 4. Value of x is 10. Okay? So I'm going to do y is equal to 40. So that would be my answer to this second problem here. Okay? Last type of problem here. Write a direct variation equation. So I know my equation is going to be y equals k times x. They gave me x and y, and they want me to find k. Remember, k is the most important. So -30 equals k times -3. So I divide both sides by -3, and I get k is equal to 10. Now, I do not box that in. That is not my answer. I have to go back to my original equation and only plug in k. Do not do -30 equals 10 times -3. That is a wrong answer. You only plug in k. So I have y equals 10 times x. That's the answer to my first part here. So I wrote an equation that relates to x and y directly. Okay? Now they want me to find the value of y when x is equal to 8. So we're going to say y is equal to 10 times 8. Y is equal to 80. So that's the answer to the second part here. So when x is equal to 8, I know my constant of variation is 10. I can find what y is equal to. So that's how you do direct variation problems.